All right, ladies and gentlemen, welcome to this lesson that I'm going to be doing on Java generics. This tutorial comes from one of the students inside of my Java video tutorials .NET course that I have. They wanted to know more about generics, and I was surprised that I didn't actually have any tutorials on the subject. So let's dive right into the good stuff. Now, you're probably already familiar with some of the concepts of generics and don't even realize that you're using it yet, and that's sort of what we're going to start with. But first, before I get into that, really the purpose of generics and why it exists in Java is really simply to be able to catch errors sooner. All right, and I'm going to illustrate this with an example. It's all about catching errors sooner. So instead of catching them at runtime, which is when your code is running and you're doing stuff, and you might hit a scenario where the code gets executed and then boom, you see a runtime error and okay, you got to fix it, and that's annoying. Instead, Java introduced this concept of generics to help pull the runtime errors out of the runtime environment, because that's usually too late. If you have a bug in runtime, they're usually tougher to find, tougher to solve, etc., etc., and they want to move them into the compile time section. By compile time, I just mean, when you get a bunch of red, or not a bunch, but a red squiggly line underneath your code. This is a compile time error that's saying whatever cannot be resolved into a type, fix it. Okay, if you have this right in front of you, it's very easy to recognize that this is a problem that you need to fix. So there you go. You find the error sooner. So that's the point of generics. Now, having said that, let me illustrate that with an example. So where I'll start here is with the other advantage, which is it's better for casting as well as for pushing the possible errors into the compile time section of your code. So the first thing that I'm going to show you is how you can use it for better casting, and then we can move into more of the catching the runtime errors versus compile time errors. All right. So when we have better forecasting, when I say it's better for casting, we can use this as an example. We have a new list, we'll call it an array list, and we're going to use something called the raw type. Let me just import these types, Java util list and array list. We're going to be using the raw types. So if you've seen this before, you might be wanting to put in the type for this array list. You might want to do something like putting in a string. Okay, because you want to specify that the contents inside this list are going to be string objects. So that in and of itself, if you have the urge to do that, that's generics right there. You're using generics. That is where generics appears inside of these angled brackets within the syntax of Java. All right, but that's sort of getting ahead of myself. Let me step back and leave it as a raw type and talk about casting. So if we have just a list, we don't specify what's going into the list, then let's say we add strings. So let's say a string, and then we can say, list.add another string or something like that. And we know as a programmers that have created this code, that we want to put strings inside of this list because we're putting strings inside of this list. But the drawback to this is when we want to retrieve the data from this list. So in order to retrieve data, we say, list.get, and we specify an index. So if we get the first element and we want to assign that to a variable like, let's say variable s, this doesn't work. It's underlining it in red because you need to cast, because right now it's assuming you're just using the generic object inside of the list. So whenever you store something in a list, it's going to store it as the generic object type. So when we want to assign this object to a string, we can't go that way. We can't go from an object to a string without a cast. So we need to add a cast to make this code compile. All right, and that's just annoying. It's annoying to have to cast all the time. Anytime that you're retrieving data from the list, if you had to cast, that would be, like I said, a huge pain in the butt. So the solution to that is generic. So instead of using the raw type, you can actually just say string. Okay, like so. And then this renders the use of the cast completely redundant. We don't need to use this anymore. So we can remove it, and there you go. Now you no longer need the cast, and you can create a second string and say list.get index 1, and then there's no compile time errors. All right, so that's just a quick illustration of why using generics will save the big headache of having to cast all the time. big annoying thing. So there you go. You've already been introduced to the topic of generics before. You probably just might not have realized you were using it. Now, the other thing that I want to mention, this is a neat trick that I actually just learned today. I don't even know why I didn't know that you could do this, but in doing some research for this video, I realized that you can do something called using the diamond. It's kind of a silly name. All it means is you can remove, when you've already declared the generic type sort of on the left-hand side of your argument, you can actually remove the type from the right-hand side and just use the open and close brackets, which they call the diamond, because I guess it looks like a diamond when you put the two together. This allows, you're completely allowed to do this because Java will know through inferring the type here that that's what you want to put over here. So because you've declared it as a string over here, it knows that you mean to put a string in here, but you're just omitting it because you want to save time. So the same thing goes for, let's say, if you're creating a map of, string or maybe integer and string. Again, these are generics I'm using. A map equals new, let's say hash map. You can just use the angle brackets. Okay, let me import the types so that I'm proving it. There you go. So I don't have to put in the actual types over here. The other thing that's really that's helpful is what happens if you're using a list of strings. This is another thing you can do with generics, is you can use sort of generics inside of generics. So you can use a list of string to be storing inside of a map. All right, but look what happened. This is okay with compiling because I've just used a diamond. So it's going to infer this as the type over here, so you don't have to use it, because it's really annoying to have to type it out and then have to say, integer again, comma, list, string, etc., etc. It's annoying and it takes up a lot of space to do that, so you can just take it away and use this diamond. So that was kind of neat. I didn't realize you could do that. It's certainly going to save me a lot of typing in the future. So now let's move on to using or showing how you can use this concept of generics like we have here inside of the actual definition of classes like the list. Okay, so here we're just using the type. We're using, whatever sort of generic type you want to throw in there. We're actually using the type itself. We're not being very generic. We're making use of generics at this point. So let's talk about how to start the creation process of actually using generics at its core. So I'm going to do what I'm going to do is I'm going to create something called a box class. This comes straight out of the documentation from Oracle itself. You can find this stuff. Let me see what website it was. Let me open it up right here. So it's docs.oracle.com/JavaSE tutorial Java generics. There you go. So you can go to the this URL to actually access the stuff that we're talking about today. Okay, they have all these different topics that you can go into and dive into and learn about. I'm going to be skipping a lot of these because a lot of these get into the really big nitty gritty details of this stuff. So feel free to go into any part that I may not have touched on and learn more for yourself. But I just want to give you the sort of the 80-20 of what's going on here. The 20% of the stuff that you're going to be using 80% of the time. So having said that, let's create a public class box, and let's start it using non-generic form. So let's say we want to store an object in here with just a typical getter and setter. So let's say we want to store an object, call it obj, and then I'm going to quickly create getters and setters by using my shortcut here, generate getters and setters. Boom, boom. So we've generated getters and setters. So now you see here, this is one way of being sort of generic about it. I shouldn't say generic. You're sort of being generic in that you're using the type object. So you can pass in, you can use whatever object you want for this particular box. But you're not really, there's no compile time checking here. Okay, that's the whole point of generics. So what I've just created here with the box object is sort of like a list. Okay, it's not a list because there's no list functionality, but it's sort of a placeholder, a representative of a list. So let me create another test class, call it public void, let's say boxes test. And inside of here, what I'll do is I will say list of boxes, I'll call it boxes, equals new array list. Okay, I can use the diamond. There you go. And I need to use my curly brackets, or what do they call it? Parentheses. So now what I can do is I can say, boxes.add, and I can say new box. And actually, let me take this out. Let me remove this box from here and create it as a sort of a variable outside. And then I can say box.add, or what do we say? .set object, and we'll say, a string. So it's the same concept as we were doing up here with a list, only let me create another box. We'll call it box2 dot set object, and then we'll say another string. And I guess to make it consistent, let's say a string is a lowercase s, and anyway, it doesn't really matter the nuances there. But and then we can say boxes.add box and box2. All right. So now what we've done is, again, we're in the same situation where we're adding, these sort of objects to these boxes, and then adding the boxes to a list. And when we're setting the object, we're just creating strings. So it's the same concept as above here. We know we're using strings, but we're not telling anybody that we're using strings. So that if anyone were to retrieve the boxes from the boxes list and then try to retrieve the data inside, they would have to cast it to an object or to a string, knowing ahead of time that they are strings that are stored in there. So let's now introduce the concept of generics. Okay, let's go back to the box and let's introduce generics. So what we do here is we want to use this sort of naming convention that they have for generics. It's always a single character, and it's always uppercase. Okay, single character, uppercase. Great examples. Actually, I could probably go back to this article and look at some. I'm sure there's something in an article here. Here it is. So the type parameter naming conventions. So you have E here for an element that can be used extensively in the Java collections framework. So when you're talking about, E could be anything. It's just an element. K could be representative of a key. So a generic key. N for a generic number, T for a generic type, V for a generic value, etc., etc., etc. You can use whatever sort of letters you want, but this is the convention. This is typically what's used as the uppercase single letters that are used inside of generics. Okay. So that might be confusing, like why am I talking about all these different things? Well, this is exactly where we can introduce it. So we want, for our box class, we want to be using a type, right? A generic type. So when we had a list before, we had a list up here of strings. But the whole point is that string could be whatever you want. You could do list of integer, right? You can do a list, and then of course it captures all the compile time error there, which is beautiful. That's the whole point of this. It could be a list of boxes. It could be a list of whatever you want. Okay, but how you represent that as the whatever you want is to use the generic uppercase T for type. Okay, because like I said, let's flip back to that article. T is what we use for type. Okay, we could have used another letter in here. I think we could have used E if we wanted to. We could have used, I think we could use A, we could use B. You could use whatever you want, but typically from a naming convention perspective, you should stick to T, because T stands for type. So now that we've sort of introduced this, we've introduced the class to this concept of the fact that you can use a generic type, and the generic type that we're using is T. Okay, so now let's take a look at what's generic in here. Typically, with respect to generics, we can replace the word replace object with your generic type, because that's what the type is that we're talking about. The type of this particular variable is object. This particular variable's type is object, and that is what we want to make generic. So we replace object with our type, which is just T. Okay, replace object with T. Replace object here with T. And there we go. Now we've just genericized, is that a word? We've made this entire class generic, which is incredible because it was so easy. All we need to do is replace the word object with the letter T. Okay, specifically uppercase letter T. All right, so now let's go back to our stuff down here. And now you see that all of a sudden, all the instances of boxes that we had before that were not underlined in yellow are now underlined in yellow because they've become a raw type. Because now it's expecting, when you look at the class declaration for box, it's expecting a generic type here, and we are not providing it. So now what we can do is we can say, well, hold on a second. Previously, we were saying that we were putting strings in here, and we know that we want to be putting strings in here, so now why don't we specify that we are going to use strings, right? And the same goes for all these other references with boxes. So we'll say box with string, box with string, and then we can actually use our diamond over here and our diamond over here, or obviously you can substitute the word string, or you can substitute the diamond. Either one will compile just fine, and there we go. So now we have compile time checking built in, and what I mean by that is if we were to replace this string with an integer, Boom, there you go. Compile time checking. Now this happens at compile time as opposed to at runtime. If someone were to try to put the number 1, 2, 3 into our box number 2 before, without it being sort of genericized, if that's the word, then it wouldn't be until runtime when someone tried to retrieve this value that they would have gotten received an error. All right, so there you go. Now we've pushed it to compile time. Beautiful. That's the whole point of this exercise. Now, having beat that dead horse completely, let's move on to other more advanced topics with respect to generics, because it gets we can go way down the rabbit hole with this stuff. It gets really, really cool. So let's dive into the next part. Let's talk about multiple type parameters. And what I mean by multiple type parameters is this right here. This is a type parameter, and I want to show you that you can actually use multiple type parameters when you're dealing with generics inside of Java. So what we can do to illustrate this is let's create another object. Actually, let's create an interface, because I want to show you that you can use them with interfaces as well. I'll say new interface. We'll call this pair. So to represent a pair of objects, let's say, sort of like let's say a key and a value. Okay, this sort of is a representative of a map, so to speak. So we can create a public interface pair, and here we want to store a key and a value. Okay, so remember back to the article. Where is it? Here, the article says K for key and V for value. Those are just sort of naming conventions. You don't have to use those letters, but it's nice to use them for other programmers so they can kind of immediately get the gist of what it is that you're getting at. So with the pair, you can use key, right? K for key, just like we used T before. Now we can use K. And since I'm talking about multiple parameters, you can actually put a comma and then put V for value. So now it's saying you have two different unique generic types. This is saying this is the first generic type, so this could represent a string, and then this is the second generic type, which could represent a different type. So if K is a string, V could be an integer. If K is a string, V could also be a string. If K is a string, then V could be a box. Right? The point is that there's two different unique generic types that could be two different types when they're being actually invoked and used inside of your code. Okay, that's just the point I was trying to drive at there. So we have key and a value, so let's create some public methods that will return the key and the value. So again, normally we would say, okay, the return type, we would say if we had a getter method, so we want to say get the key, right? We would need to give a return type. So I'm just putting void here so that it gets rid of the runtime or the compile time exception, or error, I should say. But instead, I want to give it a return value. So normally this is where we would say string, or this is where we would say integer or something. But the whole point is that this is generic. So we don't want to give a specific type. We want to give a generic type. So what is the type of the key? What is the key's type? Well, we want it to be K. Not V, specifically K, because K is the key's type. So what do we put here? We put K, meaning we want to return K as the type. And then for the get value, okay, what is going to be here? Well, I'm pretty sure you'll figure it out. It's going to be V. So V is the return type for value. K is the return type for key. Sound good? And then I guess that can be our interface. That was just to show you that you can use this stuff on an interface. That's all that I've created that for. Then we can create an actual class that implements that interface. Like let's say from the example they used was the ordered pair, I think. So we can have an ordered pair which still uses K and V, and of course it implements, right? Has to implement the pair interface, and we also need to specify it uses the pair with K and V, right? So also need to add the unimplemented methods. Okay, and if I hadn't done this, if I hadn't added the pair with the K and V, then of course we're using a raw type, which we've already seen. Raw types are not great. It's better to tell it the types that we're going to be dealing with, which is why I included the K and the V. So now there you go. I've implemented the methods that we had inside of pair. So of course it's doing the override for the get key and the get value. So then of course that sort of suggests that we should be storing a key and a value. So let's do private key, K is key, and private V is value, right? And I guess we should probably just name key and value just because it's nicer. It's, why be, whatever. You get the point. So the key can return the key itself, I probably can say this dot key, and the value will return this dot value. All right, so now we're still sticking to the generic point of this entire endeavor, right? And then maybe we can create a constructor too, because I think they use a constructor inside of the example. So we'll say public ordered pair, and ordered pair gives a key and a value, and then we can say this dot key equals key this dot value equals value. There we go. So now that's, again, we're still sticking to our guns with respect to the generic types that we want to be using here with the K's and the V's, right? So now how would you actually use this code? So let's go back to our generics examples, and let's actually use this code. So let's create another test, and we'll say public void, I don't know, pair, or using pairs, like so. And how do we use it? Well, we want to, let's say we want to instantiate a pair because we want to use the interface, just like we use list, right? We don't start list equals new array list like this. We don't start with array list. We want to start with the interface. So the interface in this case is pair. Okay, let me just comment that out. So we have pair, and we want to pass in the pair. So this is where we get to implement the types of generic, the generic types that we have specified. Remember, it's K and V, but we don't use K and V at this point because we want to be specific. This is the actual usage of the generic code. So the key in this case, place, time, whatever, it can be string, and the value can maybe be string, and then we'll say p1 equals new. And then what is the type that implements the interface pair? Well, it's ordered pair. And we can use our diamond, right? And let's say we want to, I don't think, because I created a constructor, it's probably saying, oh, it cannot infer the type, the arguments for ordered pair. Interesting. So maybe I do need to say string. Sorry, I put those in the wrong place. String. And here we also created a constructor. That's what I was expecting. So it's expecting a constructor with two strings because that's what we have inside of the ordered pair. We have an ordered pair constructor which takes in the key and the value. So now we can pass in a key and a value, which is say, a key and a value. Right? So there you go. Boom. Now it all compiles correctly, and you have that obviously compile time check in place. So, or we can create an integer and a string. I'm sure you get the idea, the concept here of what's going on. Ordered pair, and integer and string. And then here we can have an integer 1, 2, 3 and a string of a value again. Beautiful. Now again, I want to take away this diamond. I want to see if it can infer the type. There we go. So now it's inferring. So perhaps that was an issue before because there was no constructor. So maybe that's the problem. If we take away that, that's probably the issue because there's no constructor here that we've specified, the blank empty constructor. So I think that's the reason why. So we can actually use the diamond in this case if we like, right? Right. Beautiful. So that is how you use sort of the whole point of this example was to teach you about the multiple type parameters, that you can use multiple types inside of your classes, right? So very good. So now I want to sort of move things along and maybe start to talk about some bounding for our parameters, because you can also specify bounds for our type parameters. So what in the world is a bounded type parameter? Well, what I'm going to do is I'm going to go to our box example here, and I'm just going to create another, just because I'm lazy, I'm just going to create another method in here that makes use of this bounded type parameter sort of thing that we're working on here. So how do we do this? Well, what we can do is we can add, let's say we want to add an inspect method. So we want to add a public void inspect method that will inspect the type of the generic type that we are using. Now what I'm going to do is I'm going to introduce another type. So on top of the T type, I'm going to add a second type, which is U. Now this is going to serve as a good example. I haven't sort of, we've sort of seen this, but this is exactly how you introduce a type parameter to a method. Okay, so you add it just before the return type. Okay, so you see what we're going to do here is we're actually going to be using this sort of variable or this generic type inside of the scope of this method. So this is sort of the syntax for what we wanted to do. So note that this isn't the same as this. Okay, what this does is this means this is a return type. Okay, we're returning a generic type of u. That's not what this represents. All right, just wanted to point that out. So, I mean, we could have done void, we could have done string here. The whole point of this is to say that we're going to be using the u type inside of the scope of this method. Just like we put it up here, right? We're going to be using the t generic type in the scope of the entire class. Make sense? So let's go back to void because I don't want the inspect method to do anything. And what I wanted to do is just return the actual types of the generic types that we're using. So the t and the u. However, I want to add a bounds. I want to add a boundary to this particular variable. I shouldn't say variable. This particular generic type. So the generic type of u, I want to add bounds to it. How do you add bounds to it? Well, it's just like using the concept of inheritance. Okay, or extending type of thing. So we want to extend, we want to say that u extends another type. So in this case, we could say, let's say it extends a number. Okay, this is an example that is provided by the Oracle documentation. So u extends number. So what that means is our generic type of u has to have a bounds of the number type. So we cannot substitute a generic type, or rather substitute a type in for u that does not extend the number class, the number type. Okay, that might be confusing to talk about, but I'll show you what it actually happens in the examples going forward. So let's do a system out on our two types here. So we'll say, I don't know, the t type, which is really just the object. We'll say object dot get class dot get name, so we get the name of the class, and in here we'll say u is the same thing. We'll say, oh, I forgot to pass in u, my apologies. U is being passed in the parameter list here for the inspect method. Okay, that's why we need to use u in this format here, because they're using it as a parameter, and we're going to be using it inside here where we say u dot get class dot get name. Okay, if I did not use u here, then I don't believe it would know what u was, and you would get an error. It would say, you know, what the heck is u? I can't resolve this into a type. Sound good? So let's add that back. U extends number, very good. So now we can make use of this inspect method. We can go to, let's say, our generics example, and we can, where can we throw this in? Let's just use it inside of our existing boxes test. So we can say box.inspect. Right? And we can pass in the type. So what type do we want to pass in here? Well, the first one that we're already using for the variable box, because remember, this just represents the box variable, not the box2 variable. So the box variable is already using a string. And remember, that string is being used over here, right? That's the type that we're passing into the box variable here. We're using the type of string in place of our generic type. Now, the other type that we want to use is this type u. This can be anything we want. So in this case, let's do an integer. We'll pass in an integer. Okay, oops. And there you go. So now we're passing in an integer into this inspect method. So it's not only going to be outputting the value of this as being an integer, but it should also look at the value associated with the box variable right here. Essentially the class level generic type, if you will. So it should output both of those. Let's go in and to boxes test and run it. Okay, and there you go. So down here we have t is a string and u is an integer. Fantastic. But remember that we added a bounds to the u generic type. Okay, so an integer is perfectly fine. We could have even done a double, 123.0. Let me rerun the test, and that should change to a double. Fantastic. But if we do something like we pass in a string, so another string, now this is where the compile time checking kicks in. So now at compile time, we said, oh, hold on a second. You're trying to pass in to this inspect method an argument that is not doesn't fit our description of u, which extends a number type, right? So a string is not a number. It does not extend from number type. A string is a string. So it gives us a compile time error as opposed to a runtime error, which I'll say again, beat that dead horse and say that's the whole point of generics here, is to catch these errors at compile time, not at runtime, because it's much better to have a compile time error blow up in your face as opposed to a runtime error. Much quicker and easier to catch. So there you go. That's how you sort of use add bounds to your type parameters. So now next thing I want to talk about is something even cooler, even more generic, if you will, and that is the concept of wildcards. So let's dive into that now. So now the topic of wildcards is actually fairly confusing. There's a lot of people out there who do not understand how the wildcard works, and I do count myself amongst those people who still struggle with this concept. So after a lot of research that I just did, the best way that I can explain this concept to you is in this way. So when you are using something like our example for the box, let's say, when you say that you want a specific type here, it's definitely it's not restrictive, but you can actually make it a little bit less restrictive, even less restrictive than it already is, even though it's not really that restrictive. So you can see how this is sort of an interesting sort of situation going on here. You know, you're using generics because you want it to be generic, but then the introduction of this thing called a wildcard allows the generic usage of it to be even more so generic. So it's like generics of generics. It's very meta, if you will. So that's why it's a little bit of a head scratcher at times. So basically the use of, like I said, the wildcard is to be able to make it even more flexible. So as a general, well, let me jump into an example, I suppose. Let's say that we want to work with some sort of a method that will provide a sum of some numbers and maybe output that sum. So sum of numbers. And then inside of the parameter list that we're passing in, this is where we can make use of this wildcard character with respect to generics. So let's say it takes a list, and we could say T. So this is the old way of doing it. I say old, meaning, 5 minutes ago we were talking about using T as a type, and now I'm saying that's old news, because now we're talking about wildcards. But let's say we take a list, and let's say this is a list of numbers. What I can do is, instead of putting T in here, I can put a question mark. Okay, so question mark is this wildcard character that I'm talking about. And there's sort of three ways to use the wildcard. One is to use it in this context where you just use the wildcard character of question mark, which is literally saying, pass in anything. Pass in any object that you want, which is not very different from saying list T, which is still just a type that you're passing in. But like I said, it's just a little bit more flexible. And what you can do is you can say that this extends something like the number class. So you see what's going on here? We're saying that we're passing in any sort of type so long as it extends number. Now, one thing that's kind of confusing here, that's a little bit misleading, is that extends, the word extends here, it actually means either extends or implements. So it's kind of a poor choice of words, keywords here to use. I mean, I get why they use the word extends, because it's already one that we're familiar with in terms of the Java nomenclature, the Java syntax. But it's a bit misleading because it means it can extend number or it can implement number. Okay, by that I mean it doesn't have to. It could be down a few generations from number itself. So if I were to look at the hierarchical tree for number, is there a good? Here we go. So you can be either something that you're passing in here. The type could be number, because obviously number extends number, so that would be valid. You could also pass in something like a big integer, right? You could pass in big integer because big integer extends number. Or you could pass in something like a long adder. I've never heard of that before, that type. Any of these types. Double accumulator, double adder, long accumulator, long adder. Never heard of these before, but in any case, you could use long adder here as well, as that would implement from, and extends from number. Okay, so anyway, it's in the tree. You can use anything in the hierarchy of a tree. I mean, which is not that different from extends, right? Extends is exactly that. In any case, I just wanted to sort of, preface this talk with that. Now, okay, so we have an object, we have something, a type here that extends number. So now what we can do is we can start processing these numbers, this list of numbers, if you will, and start adding them up. So we can say for number n in numbers, and then maybe we can have some sort of a variable that keeps track of the addition of all these numbers. And let's just use something like a double, perhaps. So double D equals 0.0. And then we can say D plus equals N dot, getting the double value of that number. Okay, we should be able to get a double value of any number that we pass in, so that should work in the case of using a double, because we're using sort of this casting sort of method. And then maybe at the end we can do a sys out on, the value of D. Okay, so now when we actually use sum of numbers, how can we use this? Let's not make this a test method, because this is just an actual method that we're using to process this. Another test method, we could say, public void show sum of numbers. And in this one, then we can say something like, sum of numbers, and we can pass in a list of numbers. So we'll say, I don't know, new, let's say array list of numbers like 1, 2, 3. Okay, and can I do that? Is that possible for cannot infer? Oh, sorry. Let's say integer. And can we still do this? Constructor is undefined. Oh, so I need to figure out, I forget now how the way to add items into an array list sort of inside of the constructor. How do you do that again? I think what we can do is we can use, I think it's arrays. Let's say arrays dot as list, right? And then we can just start typing in some numbers. There we go, because that should return a list of integers in this case, because we have integers in here. It'll return a list of integers which we pass in, and a list of integers is okay because integer extends number, right? So that's the flexibility that we have here. Or we could say sum of numbers, and we can say arrays.asList, and we can do 1.1 or 1.2 and 3.2 and I don't know 45.21 or something. And I think that should work, although I typed in numbers wrong. That's what the problem is. Like so. And now the as list, you see it has double, right? But it's not, there's no compilation errors because it's passing in double, and double, so the list of doubles, double does extend number. So that's perfectly okay. Let's say sum of numbers, and instead of doing all this, we can say, 2, 3 long, and 5 long. So the long value of those numbers. So now it says it's a long, and of course long extends number. Okay, so that all these will work and all these compile just fine, right? Now, if you were to, I think if we were to change this so that we had something like list of t, and define t over here. Let's see if that would work. And then, no, although, I mean, you should be able to do this as well. I mean, change type of n to t, and then, so now we need to add a cast. Oh, so that's interesting that it's forcing us to do the cast because we don't specifically know the type of t, right? It's like we want to say t extends number, something like that. So now this, this is the way that you could recreate this method using the actual types itself, the generic types. However, believe it or not, this is just a little bit less flexible for the users of this method. So people who are using this method actually don't have as much flexibility as if you were to change this back to what I had before, which is list question mark, which is the wildcard character extends number. Okay, this is where the confusing bit comes in. I can't think of an exact example off the top of my head as to where the flexibility comes from, but I assure you, this is what I did a lot of research on. People universally are saying that this is universally accepted as being more flexible for the users or of the actual code itself. So other people who are making use of this method will have less boundaries and less barriers to be able to use it. So now if we were to actually run this code, it should output all of our sums appropriately. So 6, so 1 plus 2 plus 3 is 6, and then 1.2 plus 3.2 plus whatever is 49.61, and then 2 plus 3 plus 5 is 10.0. So you can see that the logic here is actually intact and working perfectly. Now, what's interesting here is that with the question mark, you can actually use extend instead of extends, which is hard to say. You can sort of flip this around on its head. This is what we refer to as an upper bound. It's called an upper bound because the type that we're passing in here extends number. So it has to be somewhere either equivalent to the number class or number object type or lower. Right? So the reason why, so this can be lower, therefore this is an upper bound. So you see how that works? This has to be lower than this, therefore this is the upper bounds of this. So this means that the number, the type that we pass in here could be either number, or it could be double, or it can be stripe 64, or it could be long adder, but it cannot be essentially more generic than number, which means it cannot be object. We cannot pass in just object, okay? Which I believe I can show by saying sum of numbers, and then I say a list of, how would I create, just say what, new object? Is that the best way to do this? And let me save that. And then it says, yeah, the method sum numbers blah, blah, in the generic example is not applicable for the arguments list object, because list object does not extend number, right? So because we've used the extends keyword, we are essentially creating an upper bounds. Now on the flip side of that, we can create something called a lower bounds, okay, by using the super keyword. This is now turned into a lower bound, which means that the type that we're passing in can either be number or more generic, right? Because number is now the lower bounds, which means it can either be number or it can be object, okay? Because that's the number extends from object, therefore the most specific we can get, the lower bound is number, therefore the most generic we can get, which is going up the tree as much as we can, becomes object. Consequently, if we were to say super and then we were to say long adder, for example, so long adder, then adder, then that means that the lower bounds is long adder, which means the most specific we can get is long adder, which means that we can also accept a striped 64, or we can accept a number, or we can accept an object. Okay, so that's what is going on with this code. Now, what's interesting here, let me switch this to something like, I don't know, integer. What's happening is, because we're setting this as a lower bound, so the most specific we can get is an integer, what usually happens is you don't want to use this in terms of getting information, right? Because you see what happens here. Your numbers is now, there's an error here, and it's saying one quick fix is available. You need to change the type to object. So this switches from number to object, which is more generic. So essentially it's forcing you to be as generic as possible, and the most generic we can get is object. Okay, but when we go to object, then we lose the functionality of this type of code. So essentially what's interesting about using the super keyword in terms of this wildcard character, when you are using this type of functionality, it's recommended that inside of your the use of this variable, you are only sort of like adding to it or changing it or doing that kind of modification type of thing to the list itself, to the collection itself. Okay, so typically speaking, it's when you're invoking the set, not the get. Okay, you use get for extends, or rather use extends when you're getting information. Okay, so now we can change this back to number, and we're getting information from this method because we are reading from the n, right? N is our numbers is the list. We're iterating through the list and setting it equal to the value of n, and then we are reading the value of n. We're converting it to the double value. We're reading from n. So because we're reading, because we're getting from the list, we should use extends. You use super when you are setting values and variables. So for example, if we were creating this as a method that would not, instead of sum of numbers, so let me create another method. So instead of doing sum of numbers, we can do public void, add numbers to list, and we can say list question mark super, let's say integer. And I should change this extends to number because that's what we were doing. That's the more generic. Super integer, and then we'll say, I don't know, numbers. Like so, and then we can add numbers to the list. So because we are setting, we're adding stuff to the numbers, then we are golden. So we can say, I don't know, numbers dot add, let's say 1. Or we can say numbers dot add what's more generic than integer. Integer goes to number, so we can say, how do we even can you increment instantiate? That's the number, so you can't instantiate number. How do you create a number? Is there a way to create a number? I didn't do enough homework before I started writing this out, but you get the idea. You could actually put a number in here if you wanted to. What would be interesting is saying long. So you see here, when I hover over 2L, you see that it's having issues with long. It doesn't like long. It wants you to cast it to an integer, okay? Because long is here and integer is here. So they're not, long is not a, long is not a superclass of integer. Number is a superclass of integer. So that's what I mean. How can you add just a plain old number in here? Can I say like number dot? No, you can't. There's no sort of static method for numbers, and you can't say new number because it says it's not you can't instantiate the type number. You can, I don't know. I wouldn't know how to do that. You can see the anonymous inner class of, this just allows you to get the type of value from the number. So there's no really good way of showing this. But hypothetically speaking, if I was able to say new number and then, pass a number into it, then it would be okay with adding that into the numbers list as well, because number is a super type of the type that we're passing in, right? So that would be, a super type of integer, which is what we're passing in, which is number. Okay. So that's basically how you can use super versus extends with the wildcard character. And again, the wildcard character, like I said, allows you to add more flexibility than using the alternate of actually specifying the generic type. So like I said, it's like the meta, it's the generic of the generic. And typically speaking also, when you are in a situation when you need to do both reading and adding or manipulating the data itself, then you probably shouldn't be using a wildcard. Okay, so there's a whole bunch of rules and stuff around wildcards, and it does get very complex and very crazy. So by all means, I invite you to check out that article. Like I said, it's available via docs.oracle.com/java.se/tutorial/java/generics. Very, very friendly URL to be able to talk about. Not so. And there's plenty of stuff about wildcards on here. So you can look at upper bounded, lower bounded, as well as unbounded. You don't have to have a bounds on your wildcard if you don't want to. So for example, here they are sort of just printing out the elements inside of a list with the wildcard character. Okay, so you don't have to have bounds if you don't need to add a bounds. Although, so you can get pretty hairy if you don't add a bounds, because this just means anything can be passed in, and it gets pretty hairy. So, okay. Having said that, also before I end this, crazy talk on generics and how confusing it's getting, typically speaking, with the wildcard character, it's typically used in correlation with collections. Okay, by collections I mean a list or a map or an array list or any other type of collection inside of the Java Collections framework. Typically, the wildcard character is used in tandem with them. Also, typically speaking, the super, so this part, the wildcard super, is actually very rarely used. Much more commonly used is the extends. Much less commonly used is the super. Okay, just again, generally speaking, that is the case. And if you're in a situation where you're going to be doing a lot of stuff to the actual variable here, so like the variable based on this sort of generic type with the wildcard, if you're gonna be doing a lot of operations on it, like more than one type of operation on it, generally speaking, it's probably not a good idea to use a wildcard character and to just revert back to the other implementation, which is to say, t extends number, and then say list of t. Okay, so that's generally speaking a better way to do it if you're doing a lot of different things like adding and reading from it and adding to it and doing a bunch of stuff. It would be a lot of it. It would be a big headache if you were to use the wildcard character, just because, like we saw before, like if you change this to super or whatever, then you get problems here, and you need to cast everything. Everything gets more generic to object, and then you need to put in casts, and it gets really ridiculous, and it impacts the usefulness of your code based on other people trying to use your code. They're going to have all these restrictions on themselves as well, like having to cast everything in the worst case, and so on and so forth. So that's sort of a general rule of thumb. If you're only doing one thing to it, and the one thing that you're doing to it is reading from it, then you can use extends with the wildcard character. If all you're doing to it is one thing, and it's essentially just modifying it, then you can use the super, and you are good to go. Probably in all of the cases, you want to avoid the wildcard character. Excellent. So, like I said, as a summation to all this, I would highly recommend going to this article, or these articles, I should say, and going and reading up on all this stuff. There's plenty I didn't talk about, like erasures and how those work, and how sort of the Java behind the scenes will take the types that you're passing in and turn them into just generic objects. Unless you include bounds on them, then it essentially just puts in the most generic bounds that you put in, like for example extends comparable t, then it will put in that it uses comparable interface with that type, and so on and so forth. So there's a lot of cool stuff that you can read about if you really want to get into the nitty-gritty, but like I said, takes a long time to explain all this stuff, and my videos are already way too long as is, so very good. I hope that this has sort of opened up your mind to the possibility of using generics. Great real-world cases for this are something like, if I did a search on, you see all these tabs I have open with wildcards and all the research I did. A great thing that you can look at is doing DAOs. Okay, so you can say Java generics with DAOs. Okay, data access objects written in Java with generic code is actually very useful. So you can look at people's sort of usage of that. Actually, I didn't like that article very much. Now I'm searching through that one. I like the IBM one on they say don't repeat the DAO. You can create a very generic DAO using generics, obviously. So you can create something like, the generic DAO interface that has a type and with a PK that extends serializable. That's your primary key. And then you can create, read, update, and delete based with this generic Java code. And then you can go in here and see exactly how the generics work and how they're at play with your DAOs. This is just one real-world scenario of templating and generics inside of Java that is very useful. Okay, so hopefully that is a good starting point, a jumping off point for you. And by all means, I encourage you to check out all the articles that I've already talked about and get your hands dirty with this coding stuff. Because the only way that you're really going to learn this is if you get in there, dive in head first, and actually start to write the code yourself and start to fail and see the problems and the compilation errors, and then having to do all the Googling and everything like that. So there you go. Enough rambling from me. Take care of yourselves. Happy learning, and bye for now.